Welcome you. I want to welcome you to this session. This session is on plan reading, and I'm your moderator. I'm Richard Manser, and just a couple of housekeeping items. This session is not eligible for CEUs, but we will be passing around a sign-up sheet, so if you need to prove to your boss that you were here, you're welcome to do that. And we have two fine presenters here with a lot of experience. I'll read their bios in just a minute. But we're going to allow you to ask questions as they proceed with their presentations. So if you have a question, go ahead and raise your hand and ask it, and see if we can go through this. I don't believe we're going to go a full hour and a half, so we'll see how that goes. So our presenters today are John Ogden and Corey Beckamelum. John has a civil engineering degree from Utah State University. He has 6 years with Idaho Transportation Department in construction design and traffic and safety, and 9 years with UDOT Materials and Construction. And Corey Beckamelum. Corey has been working for UDOT for 22 years. Notable projects include having worked on 123rd South, 114th South reconstructions, and the first phase of the Mountain View Corridor. So please welcome our speakers.
Okay, it's working. So thank you. Good turnout for 8 o'clock in the morning. I'm impressed. So thank you for coming out and so, like it was told to you, this is Plan Reading 101. To start out with, one thing that I was impressed with, Corey, for a long time now, has been doing presenting at a maintenance academy. So he's been doing that for quite a while now. But one thing it shows to me is Corey's devotion to developing personnel and technicians at UDOT. So he is an easy person for me to rope into presenting today, so thank you, Corey. So standard drawings and plan sets, why is this important? So one thing we're going to cover, this is basically what we're going to cover. We're going to cover why do we need to know this? Why do we need to understand plan sets? And then the relationship between standards and plans. We'll cover a little bit about the standard drawings and then also plan sheets. So I've got up here, I've got our UDOT standard specifications and also UDOT standard drawings, and I'll cover some of those. Let's go next slide. So starting out in construction, I started with Idaho DOT about 15 years ago. And fresh out of college, they gave me a construction project. It was on a side road off of US 95. US 95 goes from the Canadian border to Mexico, so it's a well-traveled highway, US highway. Off US 95, there's close to Sandpoint, Idaho, there's a road that the Burlington Railroad uses. So on the side road, there's the railroad, and they were widening the road to accommodate an overhead sign structure that had the flashing lights for the railroad. And then also for school buses, they wanted to accommodate a place where they could stop, open the doors, safely cross. So the railroad was skewed at an angle, so this was also an area where they've had some accidents, so they wanted to do some safety improvements. So first thing going out, the contractor, you kind of have your larger contractors that are used to state construction work. This was the first time this contractor had state work, so he was unfamiliar with how state government operates, and really going from one DOT to the next, they all have their standard specifications, standard drawings, and pretty much, it's the same type of standards from one DOT to another. So I get out first day, the first thing they do is they're setting up traffic control, trying to work on the shoulders and off the shoulders, and so they bring out these temporary temporary signs, you know, the road work ahead and all that. So what they had for their sign bases, they brought out these tires that were filled with concrete that had a metal sleeve in it. So all you had to do was put your 4x4 signposts in these stands, and I was thinking, man, this is kind of a flashback. You know, I know Napoleon Dynamite was filmed in Idaho, and I saw at the end they were playing tetherball, and Napoleon Dynamite, he can whoop on anybody. But, you know, basically you have to, on construction projects, there are certain standards that they have to meet. And for example, on traffic control, we've got our standard drawings. There's a traffic control section, and they have to meet certain requirements. A lot of the barrels and other safety devices are crash tested. So there's been quite a bit of research put in on crash cushions, on barrier, and basically those standards are what gets incorporated into our standard drawings and our specifications. So in this instance, you have to be a referee and tell the contractor, no, this isn't acceptable. You know, bring out something that meets our standards. That touches, so that's kind of why this is important. Let's see. Oh wait, we could go back. So kind of at the start of the project, as they're putting a project together, they identify a need. A lot of projects are identified based on safety improvements. It might increase capacity, might replace deteriorated pavements. So once a project's identified, you know, in my mind, there's nobody that knows an area of road better than our maintenance foreman. So, you know, at the start of a project, having a shed foreman give their input on problems that they have seen in this stretch of highway. Sometimes it might be just outside the limits of what's originally identified. And if there's an issue that we can extend the limits and accommodate the need of what's been identified by the shed foreman or other maintenance workers, then you know, limits can be expanded and cover those needs. The reason to try to get that into the plan before it goes out to contract is that once the project's awarded, then the costs go up from there. If anything's added into the project, then that would take a change order to accomplish, which can be done, but sometimes, you know, as being a steward of taxpayer money, sometimes the cost that comes back to us is not reasonable to accept. So trying to get items identified in a project at the start of the project is crucial. So starting out, you start out with plan reviews. A lot of times we'll go out on the project and just kind of do a drive-through, get out and see some of the items that need to be addressed. So that's a plan review. Plan in hand. So the project development starts on plan sheets and developing the contract and specifications. So then we have a review with what's called a plan in hand. So in essence, this is approximately 50 to 60% of the design work is completed at this phase. And then the PS&E, after they've further developed and addressed some comments from construction, maintenance, and other traffic and safety, other people, then they further the design to plans, specifications, and estimate, or PS&E. And this, you know, they're pretty near complete on the design of the project, probably 80 to 85% complete. So, talking about the plans, you know, like I mentioned, putting a project together, we ensure that maintenance needs are taken care of, safety issues, and then looking for ways to save money, do things more efficiently. So standard drawings talk about, so when I refer to standard drawings, we've got a whole bunch of different sections. For example, we've got sign bases. If there's an overhead sign, the sign foundation, basically the same design can be reused instead of redesigning on every instance where there's a sign base that needs to go in. We can refer to the certain standard and use that for acceptance. So, you know, did you know on those overhead signs and traffic signals, you know, one thing that they're designed for is a wind load. So, you know, I don't know to what mile per hour of wind speed they're designing to, but I know that's taken into account is the loading on those big, large signs. So also for an example, on crash cushions, there's a whole bunch of different crash cushions based on the barrier, if it's concrete barrier, if it's guardrail, if it's in the median on the shoulder. But basically they can refer to a crash cushion or end treatment, and then we've got a standard. We're not repeating the same design over and over again. Yeah, go ahead. All right, so order of operation in our spec book, this is defined. So, you know, we've got this standard specification, standard drawings, contract provisions. So how do you know where to look to kind of what supersedes the other? So in the contract, the special provisions are specific to that project. So it might be a supplemental or something in addition to what's already our standard. So that's why in the order of operation, the special provisions are what supersedes our standard specs. So if there's a discrepancy from one to the other, the special provisions is what stands. The next order would be the plan set. So the plan sheets are made specifically to the project. They have the alignment of the roadway, and then, you know, they'll make reference to, for example, the barrier that's installed in the end treatments, and they would make reference to the standard drawings. They would also have plan-specific details. So supplemental specifications, that's in, the supplementals are also in the contract, and those are updates to the standard specifications. So there's updates periodically on standard specifications that are, by the way, all the updates to the standard drawings and standard specs are on UDOT's website. So there's those updates periodically, and also the supplemental drawings, it's the same thing to the standard drawings. In a contract, measurement and payment is for each item of work that the contractor does. It describes how things are measured and paid for. And then the other order of operations are standard specification and standard drawings. So when do I need to look in the standard drawings instead of the specification? So like the previous slides show, the first things are contract specific, and they'll supersede the standard drawings. So when you would need to look in the standard drawings is when your plans and plan specific items and drawings make reference to the standard drawings, like on the crash cushions, you know, the different types. So that's when you'd need to reference the standard drawings. So standard drawings, so they've got, so this bicycle theory that we've got up here, basically your standard drawings kind of give you more of the details, like on a bicycle, what kind of paint to use, what are the specifications for the paint on the bicycle, what's the seat made out of, and so the contract would basically describe basically how to put it together.
Yeah, take over for a sec, sorry to butt in. What the bicycle theory is, if you're gonna build a bike, the frame will be in the standard drawings. It's gonna tell you the diameter of the wheels, the size of how to build the frame. How's the frame supposed to look? You'd go to the standard specification to know what type of paint, what color of paint, what's the seat supposed to be made out of, what type of reflectors. So one gives you the dimensions, the other one gives you what it's made out of type of stuff, so.
Thank you. All right, let's go next. All right, so like we were describing, the first order of operation when you're looking at the plans, look in the plan set first and the standard drawing second. Generally speaking, plans tell you where to build it, and the standards tell you how to build it. So also look in the standard drawings when there's no specifics in the contract, then that's when you refer to the standard drawings. And then on maintenance contract and when UDOT does their own work, a lot of times they'll install items of work along the highway according to the standard drawings. All right, now we'll get into a little bit of the how the standard drawings are organized. They have an index sheet. Starts with the advanced traffic management system, and then it's alphabetized. So you've got barrier, general work, there's a bunch of other descriptions. So this is kind of the first sheet in the index that describes the title of each sheet, what each of the standard drawings entail. Okay, and then so in the standard drawing, I'll come over here. This is you find your own 3-ring binder, but UDOT can issue a set of standard drawings, and they've got it tabbed just like it shows on this next page. So you've got easy reference to what you're looking for: barrier, catch basins, crash cushions, drainage box. Okay, and then on each sheet on the right side of the drawing, they've got a drawing number, title, engineer's signature, the engineer that designed and accepted the drawing, the date that it was accepted, and then any revisions to it is also on that same title box. So on the right of this sheet, this is standard drawing for a manhole cover, and then on the right you see those boxes that I was talking about. On the upper right is the revision, so any revisions done to this drawing would be updated and labeled in that box. The middle box is the engineer's signature that designed and accepted the drawing, and then down in the bottom right is the page number and sheet reference. So a lot of times the standard drawings might have more than one sheet that pertain to it. Yeah, go to the next. So on a standard drawing, there's different views that could be labeled and identified. So a plan view is an overhead view looking down on what's being placed or installed. Profile view is looking at the side view along the length of the object. Typical section or cross section is if you cut the item in half and flipped it on its end, and you see the different layers that describe the item. And elevations, the front or side view looking in. So, and here's that same plan sheet again, so you could see the different views. So section BB would be your cross section. The upper left is that top view looking down. Different components, the frame. So there we go. We got it better described here. You got the plan view of the frame, and then the typical view cross section of that same frame and lid. Okay, on standard drawings, a lot of times you'll see tables. In the drawing, they might not have enough space to type out the full description of what the drawing entails, and so, for example, on this drawing, it's got a slope table. This is for pedestrian ramps, so ADA ramps have different requirements that every ped ramp needs to meet. So you'll see up there, there's the C and the R and the L, and that's reference to this table. So instead of typing out landing or ramp or clear space, all those items, they'll just label in the drawing these different letters, and then that refers you to the tables. They'll also have notes, so on the same sheet. So here's some other ADA ramps on a different standard drawing, but pay particular attention to these notes. They describe details to each of the ramp that pertain to requirements of installation. A lot of times, like on this sheet, it makes reference to the standard drawings of another one it's basically the general instructions on installation. Okay, so now I'll turn it over to Corey.
Okay, like John talked about, that was our standard specifications and our standard drawings. And in a nutshell, what that is, those drawings can be used no matter if you're up in Logan or if you're down in Moab. That's the standard of how we do things. When we get into the plan sets, these are unique to that specific project. Okay, you can't go from one project to the other project and use it. It's for that particular project. Okay, in a plan set, you're going to have what they call a cover sheet. And in that cover sheet, it's going to have the project number. Can you go to the next slide? See, you're going to have a project number, which is like the F-021, which is SR201, 21 for the pin. It's going to tell you where it's located at, the county that it's in. It's also going to tell you the milepost and what we're doing. So if you look at that little Utah, it's going to tell you if you're a contractor going to bid on this job, it's going to show you the location. So if you think it's in Garfield County, you'll look at it, it's actually in Salt Lake County. Okay? Then in the plan set, as you go through the plan sets, they're going to have an index. So in the index, go to the next slide, it's going to tell you what does this plan set have in it. It's going to have summary sheets. It's going to have environmental sheets. It's going to have your typical sections. It's going to have your drainage sections. You're going to have all these different sections in there. We're going to talk about what some of these are. Okay, like John said, in the standards, we have typical sections. We have them here too, cross sections. They are the width of the roadway. It's the type of material, side treatments, and how wide are the lanes? How wide are we building this road? Go to the next section. This happens to be a cross section of a job we did up here in Region 2, Alpha 201. It's a cross section of the bridge and also the roadway. You can see it's telling you where's the barrier going? How many inches of asphalt? How many inches of untreated base course? How wide are we having to build this? This is the sheet that you're going to get this information on. So if you're a contractor or you're an inspector and you want to know how many inches of HMA do I have to put down, this is the sheet it's going to tell you. Okay. Summary sheets. What summary sheets are, it's the estimated plan quantities, where it's located at, and the items to be placed or removed. When the designers come in to design the project, they come up with an estimate of how many tons of asphalt, how many trees, how many widgets we got to put into this project. This is where that data is collected. This is where this data is justified for that estimate. It says, like, I got to put in 37 manholes. It'll tell you where each one of those manholes are supposed to be. So you can look at the plan sheets, or you can go quick and dirty here in the summary sheets. Okay, your plan sheets, it's the bird's eye view. You'll be able to see curves, a right-hand curve, left-hand curve, the call-outs. These go to the next sheet. These is what we call call-outs, okay? It tells you what and where everything's supposed to be. This is the bird's eye view, looking down on a section of roadway. Everything is going to be left or right at the control line or center line. And how that is determined is if you're looking either north or east. If you're looking north, everything on the left side is going to be the left, everything on the right side is going to be right, and the same going to the east. So if you look at these, it's going to have like a station number, like 32 plus 15, 37 feet right. You know that's going to be on the right side of the road. Okay. Your plans for, like, we'll go into the drainage sections in a minute. It's going to tell you the type of catchment. Is it a CB1, CB, well, whatever type of catchment, manhole, location, depth. It's going to give you the elevations. It's going to tell you what type of catch basin. Is it a solid cover or is it a graded frame? You'll look at it. It'll give you the elevations of how deep this pipe's going to be. So as you're going to go lay this pipe, you know, do I got to dig 3 feet or do I get to dig 30 feet? It tells you what elevation this pipe needs to be installed at. Okay. Plans profile. Is the road going down? Is it going up? Because the earth is just not flat. It's going to have hills. It's going to have valleys. How do we address this? Is this a fill section or is this a cut section? Let's go to that. So if you look at it, the dotted line, you can see right here, the dotted line, that's the existing. The solid line is what it's going to be at the completion of the project. So now, oh, like right here would be a fill section. You know, it tells you what you have, what type of work has to be done. Are you going to, is it a fill of 4 feet or a cut of 2 feet? This is where you look. Are you going to also see on these type of sheets, are there going to be conflicts with utilities? It'll show the utilities that we know about and what a good estimation of what elevation they're going to be at. Okay. In the plans, they also have other sheets found in the front of it. Your survey info, detail sheets, project-specific drawings. If something's different than the standard, it's going to be in your typical drawings. It'll be in the front of the plan sets. Okay. You'll also have signing. There's signings on the job. Okay, where do the signs go? What is the legend of the sign? It's going to have your striping. Okay, is it a crossbar here, or stop bar here? Is it a crosswalk? Is it the shark's teeth for a yield bar? It's going to tell you. It's going to tell you the location. Signals. It's going to tell you where we're going to put our loops. Is it loops or is it some other detection? Is it what size of mast arm? This is where you're going to find it. Okay. And as the projects are designed and they come out, there are different categories. There's an orange book, there's a blue book, purple book, and I do believe there's a red book, but we haven't addressed the red book because those don't come out very often. What an orange book is, it's a maintenance project. Flip to the next screen. It is very specific what type of activities can be in an orange book. So if it's an orange book and the cover of the book's going to be orange, we know it's not going to be, we're going to go build a bridge. It's rotomilling, thin functional overlays of less than 1.5 inches. Rotomilling, surface sills, rejuves, lane leveling, crack sealing. Basically, that's all an orange book can be. If we want to put drainage in it, it changes it from an orange book. And if it is slated to be an orange book, that's all it can be. Okay? Basically, a purple book, in my mind, it's an orange book on steroids. Okay, we can do some little other things. We can start a little bit of drainage. We can get into some major rehabilitation on bridges. It's bumped up to the next level. Okay? So it's still, what these projects are, that's all it can be. Because if we start going, oh, we want to add all this drainage to this and it's only supposed to be an orange book or a purple book, the guidelines have already been set forth. We can't go outside of that. The next one is a blue book. These are the big projects, you know, like that core, Point of the Mountain projects. Those are all blue books, you know. These are the big, we can do anything we want. These are the big industrial type of projects. Okay. In summary, make sure you review the standard drawings before performing pertinent maintenance work for you guys are in maintenance. If you're not sure, especially if you're a new guy, and you're not sure how a signpost foundation is supposed to be in, look it up. Look at it. Go into the SNs of the standard drawings. How far down are these post holes supposed to be? What am I building? Okay. Inspector, same thing. Is the contractor putting it in right? Just because they're a contractor doesn't mean they do it right. We have to double check. Make sure the contractor is familiar with the standard drawings and performing contracted work with the plans. Do they even have the right plans? I come into it a lot of times is they have the wrong year of standard drawings, and that's something that I'll address. We didn't address at the beginning. The standard drawings have a year. There's right now we're in the 2012 standard drawings. That's the year you use. It is specified in the special provision what year of standard drawings and specifications you use. So you can't go back to like the 2008 if it says the 2012, okay? It's a set, that's the ones you use. You use a set of project plans from a maintenance point of view. We like to see the shed foreman come out on our projects and get involved. They want them to go in, especially in the design phases, get involved. As maintenance has an opportunity to have more of their input involved into the project if we get it into the beginning, where it's just the design. It becomes really hard after the fact, after the contract's already been sent out, to change things if it wasn't addressed in the plans, the plan sections, the development of the plans. Okay. That concludes this. Does anybody have any, you had a question back there?
Yeah, one thing I was going to mention before is to, just the color coding on the projects also have a lot to do with the ADA requirements as far as technical and feasibilities go nowadays.
Okay.
So, for example, like maybe you got a catch basin in the way of a ramp and it throws it out. You know, if it's not a purple book or a blue book, you might be able to get a technical and feasibility on that. But say that project was a blue book, then you actually have to do something about it. So also that color coding is really important. That's kind of your design section.
Okay. So what you're saying is if it's a blue book, you have the opportunity to fix it right. If it's an orange book, you might not have that opportunity. Is that what I'm hearing?
Yes.
Okay. Is there any other questions? Okay, yeah, we can do that very easily. Okay, stationing is an engineer's way of determining distance, okay? A station is based on 100 feet. So you'll see a lot of it in the drawings, like a 100 plus 0, 0. It's not a mathematical calculation, okay? You don't go 100 add 0, 0. It's just 100 plus nothing. So if let's say it's 100 plus 12, it's, instead of saying you need to go out there 10,012 feet, you go, all right, let's go 100 plus 12, and wherever station 0 plus 0, 0 is, that is the beginning. So if this is 0 plus 0, 0, and you got to go to a station 100, it'll just be 100 feet that way, okay? That's all it is. It's a length of distance to help gather. So if I'm going to tell John, hey, I need you to go out to station 32 plus 12, instead of saying go to 312, just go 30 plus 12, just go that direction. Okay. Yeah, correct. I misspoke. Yes, sir.
How come, like I'm new, I'm a field engineer, and how come on some of these orange books and stuff that I do, how come they're using mileposts instead of stations?
Okay.
The issue that I have is in the office, our paperwork, in order to make things line up, we have to run off of stationing in the office. And those mileposts doing that for the stationing and those books really screws us up.
You're preaching to the choir here. I understand exactly what you're talking about. Here's what, I'll tell you what it's been presented to me. Basically, an orange book is a maintenance project, okay? They do not have the funding to go out there and do an actual survey on there and actually run an alignment and actually do the station. So we'll come off the mile markers. That's to the best of my knowledge. So that's why it's in milepost. To me, I'm with you. If I was king for a day, it'd be stations, but it comes down to a budgetary thing. Any more questions? Yes, sir.
They use equations anymore?
Yes, you do. Yes. What an equation is, and thank you, Barney. That's what it's. What an equation is if you're, especially if you're in a canyon and there's a lot of switchbacks, okay? You've got sometimes because of the corners, the stations will start getting longer and shorter because of the curves. To get that back on the true 100-foot intervals, they'll have an equation. So you've got to, okay, here's the beginning station, here's the ending station, so you've got to do a little bit of math to make it up. So at that point is where they get everything back on track. Okay, that's the best and easiest way to do it. I don't see them very often. Do you see them very often? Normally, it's only in like remote areas where there's lots of curves and things in the roadway. Does that answer your question, Barney? Okay. Anything else? Hey, I appreciate your time today. Thank you very much.